Trigonometry, Chapter 4, Graphs of the Circular Functions, Section 2, Translations of the Graphs of Sine and Cosine. Video 5, Finding the Function for a Sine or Cosine Graph. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we learned how to graph a sine or cosine function involving changes in period and amplitude, followed by translations. To graph f of x equals d plus a times sine of b times the quantity x plus or minus c, we did the following. First, we graph f of x equals a times sine of bx, using quarter periods to illustrate one cycle with the correct amplitude and period. So in other words, we just graph the function with the two multiplied values, a and b. Then graph f of x equals the entire thing by applying the correct translations to the quarter period points of the graph of f of x equals a times sine of bx. In other words, we focus on the amplitude and the period to get the shape, then we focus on the translations to move that shape around. In this video, we start with the graph of one cycle of sine or cosine of a sine or cosine function and determine a possible function of the graph. I say possible function because there's an infinite number of them that would work. If you're curious about that, please read the footnote below. For example, let's consider the cycle below. Determine a function whose graph includes a cycle. This curve goes from negative 7 pi over 4 comma 0 to negative 3 pi over 4 comma 1.5, and then pi over 4 comma 3, and then 5 pi over 4 comma 1.5, and then 9 pi over 4 comma 0. To find the function, we need to answer several questions. The first of which is this sine or cosine? The second of which is, was there a reflection across the x-axis? The third question and fourth question, what is the period and what is the amplitude? And then the fifth and sixth questions are, what are the translations, both the horizontal and the vertical? So let's take it one question at a time. Let's start with whether to use sine or cosine. We determine this based on the quarter period behavior. Recall that for sine, the quarter period behavior is mid, high, mid, low, mid. Whereas for cosine, the quarter period behavior is high, mid, low, mid, high. So sine starts in the middle, cosine starts high. What is the quarter period behavior of this one? Low, mid, high, mid, low. Well, that didn't match either one of these. What does that mean? That means that a reflection has occurred. So let's see what the reflection mid-quarter period behavior looks like. When sine is reflected, remember sine normally starts mid and goes high, its quarter period behavior changes to mid-low, mid-high, mid, which is not this graph's quarter period behavior. But when cosine is reflected, cosine normally starts high. Its quarter period behavior changes to low, mid, high, mid, low, which is precisely what this is, low, mid, high, mid, low. So this tells us two things. Number one, we're going to use cosine. And number two, the value of A, which determines the amplitude, will be negative. Now let's find the amplitude. You can measure from the midline, in this case y equals 1.5, or take half the distance between the extrema. Let's do the latter. The maximum y-coordinate is 3, the minimum is 0, so the amplitude is half their difference, which is 3 halves. You could use 1.5, but I'm going to use a fraction. You'll see why towards the end. Now, because of the reflection, A equals negative 3 halves. So amplitude combined with reflection gives us A equals negative 3 halves. Now let's focus on the period. For a cycle, the period is the distance from the least x coordinate to the greatest x coordinate. So in this case, the period is 9 pi over 4 minus negative 7 pi over 4, which is 16 pi over 4, which is 4 pi. And that's not b. b is used to get 4 pi. Since the period is 4 pi, the calculation for the period, 2 pi over b, is equal to 4 pi, and this yields b equals 1 half. We now know that prior to translations, the function was f of x equals negative 3 halves cosine of 1 half x, whose graph is embedded below in red. In other words, we found the graph pre-translations, that it has the correct period and amplitude, the correct shape. Now we got to figure out how to move the red to the black, and we can keep track of the first point on each to do that. To get from 0, comma negative 1.5, the beginning point of the graph before it was translated, to negative 7 pi over 4 comma 0, the beginning point after the graph translated, we have to go to the left 7 pi over 4 and up 1.5. That means that D is 1.5 or 3 halves and C is 7 pi over 4. And since the horizontal translation was to the left, C will be added to X in this function. So A is negative 3 halves, B is 1 half, C is 7 pi over 4, and D is 1.5. Put them all into the function, and we get this final function of f of x equals 1.5, vertical translation, minus 3 halves, amplitude and reflection, cosine of 1 half, used to calculate the period, times parentheses x plus 7 pi over 4, the horizontal translation to the left. Now, we have a couple of options on how to write this. It's a perfectly correct answer, but number one, it's bad form to mix decimals and fractions. Now, 7 pi over 4 is a decimal, would not be exact, so we're stuck with it, and so we're stuck with fractions. So I'm going to change the 1.5 to a fraction, 3 halves. Looks better. Second, we have nested parentheses, parentheses inside parentheses. Although the parentheses inside the cosine show the horizontal translation, 7 pi over 4 to the right, the function would look cleaner without the extra parentheses. As such, personally, I would distribute the 1 half to get 1 half x plus 7 pi over 8 inside the parentheses. Now, do you have to do both of those things? Well, how you should format your final answer depends on homework or test instructions or your professor's preferences. So please make sure you read any instructions on how to format your answer. Now you try. Pause the video and try the following. Find a function whose graph contains this cycle. The graph goes from pi over 4 comma 3 to pi over 2 comma 1 to 3 pi over 4 comma 3 to pi over 5 to pi comma 5, excuse me, and then concludes at 5 pi over 4 comma 3. Pause the video, give it a try. All right, if you haven't paused the video yet, here comes the solution. 3, 2, and 1. The quarter period behavior, mid, low, mid, high, mid, suggests this is sine and a reflection has occurred. So the A will be negative. Our amplitude is 5 minus 1 over 4. Should say over 2 there. Let's fix that real quick. There we go. Amplitude is 5 minus 1 over 2, which is 2. So A is negative 2 because of the reflection. The period is the difference in 5 pi over 4 and pi over 4, which is just pi. So 2 pi over B equals 2. Yields B is equal to 2. Vertical shift is up 3. Horizontal shift is to the left pi over 4. Evident because of the first point's coordinates, pi over 4 comma 3, when the graph of sine starts at 0 comma 0. And because the shift is to the left, the pi over 4 is subtracted from x. Therefore, f of x equals 3 minus 2 times sine of 2 times the quantity x minus pi over 4. If you distribute the 2, the argument of the sine will be 2x minus pi over 2.